Hello, hello, hello. Good morning. It is Tuesday, the 12th of December, and today I am going to be going through TMUA 2023 Paper 1. I've been doing lots of the TMUA Paper 2s recently because that's where all the really difficult logic is. But that doesn't mean that TMUA Paper 1 is a walk in the park. So I wanted to go through one of those today, see what the technique's like, and make sure everything's okay there. I'm going to do it 2 times, so I'm going to get the little timer up. So it's going to be 75 minutes on the clock, and I think it's just going to be a case of going through. I hope that it's not going to be anything too difficult, but time will tell on that. So I don't really see the need for much faff today, so without further ado, why don't I jump into it? So we've got TMUA Paper 2, Paper 1, Paper 1. All right. Good to go. As usual, I'll be writing on the whiteboard, so we can look at the questions there. Ready? And, oh, actually, no, let's just see what happens. Ready, and go. So given that integral, and that integral, by the way, okay, so let's be quick about this. So integral to 0 to 1 of ax plus b. So in fact, let me whoop. So what that means is ax squared over 2 plus bx, between 1 and 0 gives you 1. So that's a over 2 plus b is equal to 1. And from the other one, I can say the integral from 0 to 1 of ax squared plus bx dx is equal to 1, which means that ax cubed over 3 plus bx squared over 2, if I evaluate that between 0 and 1, I'll also get 1. So a over 3 plus b over 2 is equal to 1. Let's put those together. So if I double this up, then 2/3 a plus b is equal to 2. That minus that is a 6th a. That minus that is 0. That minus that is 1. So a is equal to 6, and b is equal to that would be 3, so b would be equal to minus 2. So a plus b is equal to 4, which is f. Okay, let's move this back over. Whoop. So question 2. Graphs, you got a quadratic, you have a straight line plotted on the same set of axes. The graphs do not meet. Okay, so this will be substituting in, and the discriminant will be 0. So if I substitute that in, it would be x squared plus 5x plus 6 equals mx minus 3 for if there was a point of intersection. So x squared plus 5 minus m lots of x, that was minus 3, so that becomes plus 9 equals 0. And there are no solutions, so the discriminant, b squared minus 4ac, must be less than 0 for no solutions. So m squared minus 10m plus 25 minus 45 must be less than 0. M squared minus 10m minus 20 is less than 0. Classic case of quadratic inequalities. Does that factorize? Doesn't look like it factorizes. I also feel like this doesn't feel like it's going to give me 11s. Have I done something wrong? We'll find out. Have I done something wrong? I don't think I've done anything wrong. I'm just going to... That's... Oh my God, no. 45. Thank you. And that's important, by the way. Look what I just did. I looked at the multiple choice and it just felt off. And so that ability to check your work as you're going and get a sense check, like, does this make sense? That's very important. So m minus 11, m plus 1. So I know if I plot the quadratic, I know it's going to go through -1 and 11, and I want it to be less than 0, so it has to be between -1 and 11, which is A. Cool. I want to pick up my pace. I feel like I'm not making good pace for this paper yet. But we're going to find out. So let me zoom in just a touch. For any integer that... Oh, this is madness. Oh, I like this. Oh, I like this a lot. Right, let me lay it out. So the integral from 0 to 1 is 2. The integral from 1 to 2 is... No, lies. That is because n was on the bottom, so n equals 0. So that integral is equal to 1. That is equal to 2. Integral from 2 to 3 is equal to 3. So it's basically equal to the number on the top. Integral from 3 to 4 is 4. And integral from 4 to 5 is 5. Okay. Well, this thing is the integral. So integral from 0 to 3 is 0 to 1, and then 1 to 2, and then 2 to 3. That one there is 1 to 2 and 2 to 3. That one there is just 2 to 3. That one there is 3 to 4, which is minus from 3 to 4. And then we get that one there from 5 to is equal to negative 3 to 4 minus 4 to 3. 4 to 5 even. The idea being if you flip the limits, then you change the sign. So that will be 1 plus 2 plus 3 plus 2 plus 3 plus 3 minus 4 minus 4 minus 5. 4, 5. 5 minus 4 is 1, which is C. Okay. So here, question 4. Evaluate the sum from n equals 0 to infinity of... Let's just do the first few terms. So when n equals 0, where it's just sine pi over 3 over 2 to the 0, which is 1. I'm going to need my special triangle, 1, 2, root 3, where this is pi over 3. So sine pi over 3 is root 3 over 2. I will never in my life be bothered to learn what that value actually is. I will always go from triangle. That I promise to you. So the next one is sine of 4 pi over 3. So we're adding a pi to that. And on the cast diagram, adding pi to that is going to put me in tan. So sine will be negative all over 2. So it would be negative root 3 over 2 times a factor of a half. And then if I add another pi back in, it's just 2 pi. So it gets back to... Okay, so it's going to be... The next one is going to be root 3 over 2, again to the power of 1, this time with a quarter. In other words, I'm seeing a geometric series where a is equal to root 3 over 2 and r is equal to minus a half. So what that sum to infinity is going to get me then is a over 1 minus r. So that becomes over 3 over 2, which becomes times 2/3. Those cancel, and it's root 3 over 3, which is C. Okay. The following shape has 2 lines of reflectional symmetry. Yes, it does. MNOP is the square of a perimeter 4, so it's a side length of 10. Vertices of these guys lie on the edge of the square. MR has length of x. What's the largest possible value of x such that... Okay. So, let me draw it out myself, as you would in the real thing. So that is x, which means that is x, which means that's 10 minus x, 10 minus x, 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 10 minus x, 10 minus x. What's the largest possible value of x such that RSTU? So what's the area of this guy? Well, this is okay. Well, these are just scaled up 1 root 2s. So that's root 2x, root 2x, root 2 into 10 minus x. So the area of the rectangle is simply these two sides multiplied together, which would be 2x 10 minus x, which is the area, which is equal to 20. So I don't know that. So let me divide both sides by 2 first of all. And that's going to give me minus x squared plus 10x equals 10. I'll move this over. Come on. That should give me. I don't expect it to solve precisely. So x is equal to minus b plus, and we're looking for the largest, so I'll just do the plus. B squared minus 4ac all over 2a. So that's 10 plus root 60 over 2, which is 10 plus 2 root 15 over 2, which is 5 plus root 15, which is f, and I'm going to stick with that. 6. In the simplified expansion of that, how many of the terms have a coefficient that is divisible by 12? Ooh, I've never seen one that looks like that before. All right, let me write out the first few terms of the expansion and see what I see. So 2 to the 12 plus 12, 2 to 11, 3x. So in order to be divisible by 12, you need to have at least you need to have a factor of 3 and 2 2s in it. So the first one has no 3s. All of these will, because these all have multiple more than 1 2 and they have a 3 in them, all the way up to the other side would be 12, 2 to the 1, 3x to the 11, 3x to the 12. So this also picks up another 2 just from the 12. So this is also divisible by 2. So they're all divisible by, they're all divisible by 12 except for the 2 at the end. Now, there are 13 elements of Pascal's triangle. So 13 minus 2 is 11, which is E, are divisible by 12. I'll probably go into that in more detail in the analysis. How am I doing on time? Good. 2 functions defined as follows. Find the largest value of x such that they are in the ratio 4 to 1 respectively. So that means that P is 4 times bigger than Q. So that means that 2 to the x plus 4 is 4 times as big as, nice. All right, 2 to the 2x minus 2 to the x plus 2 plus 16. Now that is equal to 2 squared. So that becomes 2, if I add, and then in multiplying these, I add the powers to give me 2x minus 2 to the, again, we're going to add the powers and make that x plus 4. And 4 times 16 is 64. Oh, this is so good. Oh, this is so good. Because that's minus 2 to the 4 is 16. So that's 16 lots of 2 to the x. Take that across to the other side. You get another minus 2 to the x. Subtract the 4 across, we get plus 60, and we get a stealth quadratic in 2 to the x. Oh, I'm liking this. Okay. But I do just, again, inherently feel like I need to pick up the pace. So that's going to become y squared minus 17y plus 60, where y is equal to 2 to the x. Y, please factorize. 12 and 5. Largest value of x is going to be when y equals 12, when 2 to the x is equal to 12. So x is equal to log base 2 of 12, which is f. Oops, sorry, messed with the zoom. Okay. So here. In fact, let me zoom in just a touch. Okay, so triangle is called fun if it has the following properties. Okay. For a given value A, there are two distinct fun triangles where the area of S is greater than the area of T. Okay, let me draw out a representative triangle. So it's immediately looking right angle-y to me. Or if that's X and that's 30 and that's 60 and that's 90, and XY is root 3A and XZ is equal to A. So that's one of the triangles. This is a fun triangle. What's the other way I can do this, though? If that's 30, the other way I could have done it is here. I could also have put Z here, where that is also A. That would still work. So S is greater. So S is the right triangle. So the area of S is a half root 3A squared. And then the area of T is going to be the area of this smaller one, where that is going to split it clean in two there. So that becomes 30, so that becomes 30, so that becomes 30 as well, which is interesting because that means that's A. Which then splits that. Hold on, I need to make this diagram bigger. Because I'm seeing AA 30, 30 makes 60, makes that 120. So the area of T is going to be a half AB sine 120. Oh, come on. So 120 is going to be here based on an area, that angle being 60. And again, as we saw from the 1 to root 3 triangle, when it's 60, sine 60 is root 3 over 2. So it's a half a squared times root 3 over 2, which is root 3 over 4 a squared. So the area of S to the area of T is a half root 3a squared to a quarter root 3a squared. So it's a 2-to-1 ratio, which is B. I feel like there was a smoother way through that, but I got it. And that's what counts. How many solutions are there to that in that interval? Okay, so 1 plus 3 cos 3 theta is plus or minus 2, which means that 3 cos 3 theta is minus 1 plus minus 2. So you can have minus 3 on one end, or you can have 1 on the other end. So cos of 3 theta is going to be equal to -1 or a third. Now, let's draw this out. Because it was going to have a period of 360. I've divided it by 3 here to make it 120. So that's 180 because each half is 60. So up to there, okay. So -1. If it's allowed to be equal to 180, then I have 2 minus 1s. And if it's allowed to be a third, then I'm going to get 3 of those. So the 5 solutions is E. Okay. 10. Trapezium rule with 4 strips is used to estimate the integral of this thing. What is the no, what? What is the positive difference between the estimate and the exact value? Are you actually asking me to do that? Okay, maybe it's not too bad. It is very interesting. So when you put in the true values, you get zeros on both. I'm going to skip 10 for now. I can just tell this is going to be a time sink. Like, I can see how I could do it, but I just feel like there's a better way, and I'm not seeing it. Okay. So it is given that. So we can this thing y equals f of kx have the same minimum point. Okay, so y equals f of kx is going to be k squared x squared minus 6kx. It's going to have the same minimum point. Well, first of all, let's complete the square on this to find that minimum point. No, there's something in front of the x squared. So instead, let's differentiate. Is going to be 2k squared x minus 6k, which will equal 0. And so 2k squared x will equal 6k. X will equal 6k over 2k squared, which is 3 over k. And the y value, therefore, will be k squared 3 over k all squared minus 6k 3 over k. Oops, didn't leave enough room. Apologies. The k squareds will cancel, so you'll get 9 minus 18 is minus 9. So the turning point there is 3 over k minus 9. And that is the same minimum point as y equals f of x minus c. So let me just work on that. So f of x minus c is x minus c squared minus 6x minus c, which will be x squared minus 2c lots of x plus c squared minus 6x plus 6c, which is x squared minus 2c plus 6 lots of x plus c squared plus 6c. Now that's going to be more of a completing this squared situation, maybe, which will be x minus x plus 3 all squared minus c plus 3 all squared plus c squared plus 6c. C plus 3 all squared minus c squared minus 6c minus 9 plus c squared plus 6c. Cancels, 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 cancels. So the minimum point there is going to be c plus 3 minus 9. So therefore, we know that 3 over k must be equal to c plus 3, which means that k is equal to 3 over c plus 3, which is b. I feel like I could have done that faster by just locking into the x coordinates. So here on 12, how am I doing on time? Good, 51 minutes left. How many solutions are there to the equation? I don't like it. Okay. No, it's not too bad. Because if I move that over, that means that 2 to the tan squared x is equal to 4 to the sine squared x, but that is 2 to the 2 sine squared x. So it's really asking where tan squared x is equal to 2 sine squared x, but tan squared is sine squared x over cos squared x. Minus, and I'm going to move it over because you never divide by trig because you'll lose solutions. So you either have that sine squared x is 0, or 1 over cos squared x minus 2 equals 0. So in this interval, sine squared of x will have zeros at 0, pi, and 2 pi. And then we have to solve for 1 over cos squared x equaling 2. So cos squared x equaling to a half. So cos x being plus or minus 1 over root 2. Which will have 4 solutions, which is all the pi over 4 and its other values on the CAS diagram. So that's 7, which is F. Okay. 13. Point P lies on that circle. Point Q lies on that circle. What is the maximum possible length of PQ? This isn't going to be too bad. So in the first, okay, let's sketch these both out. They're both in positive x, although they do go a little negative. Okay, so we've got 2, 1 here with a radius of 4. And then we got 4, 5. It does look like we get some intersection with the radius of 4. So that's 4, 5. That's 2, 1. That should have made it all the way to the y-axis. Apologies. But the furthest away you can get is along the line connecting the centers and then extending the radius of 4 a little bit further. So let me get just the distance between the centers, which is 2 across and 4 up. So it's twice 1, 2 root 5 multiplied by, so that's 2 root 5 to go to the centers. And then I can add an extra 4 in either direction. So it should be 8 plus 2 root 5. No! Oh, I thought I was so clever with that. The radius is 4. Oh, because it's not 5, it's minus 5. Okay. Which makes literally no difference. Because the distance in the vertical is still 4. Oh, it makes a huge difference because it's 1 to minus 5. That difference is actually 6. Okay, apologies. Let me redo this. So the distance between the centers is the root of 2 squared plus 6 squared. So that's 36 plus 4 is 40, which is 2 root 10. And then I add the radius of 4 to both sides of that. So it is 8 plus 2 root 10, which is F. I'll get that redrawn to make it clearer in the analysis. But for now, I just want to put in a good run. So we have this function, 3 distinct real roots. What is the complete range of possible values of n in terms of n given 3 distinct real roots? Interesting. So 3 to okay, so I know how to do that for a cubic. To get the number of roots of of anything that's not a quadratic, you have to plot it on a graph and make sure that alternative maximum and minimum are on either sides of the x-axis, by which I mean this is a positive x cubed. So I know it's going to have to do something like this, where this maximum is positive and this minimum is negative. So let me find the turning points. So if I differentiate, I'm going to get 2x squared plus 4mx plus n, which will equal 0. 3 distinct real roots. Well, first of all, I know this will have to have distinct solutions. Are we starting to get to the hard part of the paper? How many questions do I have left? How much time? 45 minutes. I think I'm fine. We're going to find out if I'm fine. So here, I know this will have. So I'm just going to write, okay, so this discriminant has to be bigger than 0. So 16m squared minus 4ac must be bigger than 0. So 16m squared minus 8n must be bigger than 0. I'll divide through by 8 because I can. So this is one condition. N must be less than 2m squared. That is not anywhere, so I must go on. Can I easily solve that, though? I might be able to complete the square on that simply. So 2 into x squared plus 2mx plus n would be equal to 0. So let's see where this gets us. So 2 into x plus m squared minus m squared plus n equals 0. So 2x plus m squared minus 2m squared plus n would equal to 0. So 2x plus m squared would be equal to 2m squared minus n. Divide by 2. So x plus m would equal to plus or minus root of. I mean, you could have just gone to the formula. That was a waste of effort. I feel like if I plug those x's in, I'm not going to get something fun. I'm going to come back to this. So I'm going to come back to 14. So 15, the difference between the maximum and minimum values of a silly function is 3. Find the sum of possible values of a. Okay, so f of x is a to the cos x. I don't think you'd be asked to differentiate this, but we know that the maximum value that cos can take is 1. And the minimum value, so a is bigger than 0, and so it's positive. I mean, granted, I don't know that a isn't a fraction. So, but basically one end is going to be a to the 1, and the other end is going to be a to the minus 1. And we know that the difference between those is equal to 3. So we know that a minus 1 over a is equal to 3, which means that a squared minus 1 is 3a. So a squared minus 3a minus 1 equals 0. From this point, I can just complete or solve the quadratic. Minus b plus or minus square root b squared minus 4ac because that's minus 1, I flip the sign, all over 2, so that would be 3 plus or minus root 13 over 2. The sum of the possible values, therefore, the root 13 over 2's would cancel, and it'd be root 3 over 2. It would be 3 over 2 plus 3 over 2, which is 3, which is D. Okay. So here, a right-angled triangle has vertices No, what are you doing? What are you doing? That's interesting. Okay, no, let me try. Okay, I'll try and sketch this properly just to see what's up. So it's going to be 2, 3. It's going to be all the way out here, 9 and minus 1. And it's going to be 5 and something. Where that's 2, that's 9, that's 5. So how can I draw right-angled triangles on this? Well, first of all, I know that this will be one of the sides. And for it to be a right-angled triangle, it would need to be the angle formed in a semicircle. So where one of the sides of the triangle is the diameter of a circle. So I could draw one. So I could draw a right angle like that. That could be one of them. So I could draw it where it's the long side. I think I can draw it where it's their hypotenuse. I can draw it where it's the hypotenuse where something like this. Can I draw it where it's the short side? It was the short side, it would need to, yes. Yes, I can. Okay, so in other words, let me go back to, so it's going to be either, let me just draw out my 3 cases. And let me get the distances between these points. So from 2, 3 to 9 minus 1, that would be the root of 7 squared plus 4 squared. So 49 and 16 is 50, and 15 is root 65. No, let me instead do this by gradients. So the gradient here, so one of the gradients locked in, it goes down 4 for going across 7. So finding out where that's perpendicular. So it's either the gradient, so k plus 1 over minus 4 could be equal to 7 over 4, which means that 4k plus 4 equals minus 28, which means that 4k is equal to minus 32, which means that k is equal to minus 8. There we go. We're getting somewhere now. Or we could have the case from this gradient that k minus 3 all over 5 minus 2 is the one that's perpendicular to this, which would make it 7 over 4, which means that 4k minus 12, and that's 3 equals 21. So 4k is 33, and k is 33 over 4. Or we could not have it that is the one that is perpendicular, we could instead have it such that k plus 1 over minus 4 is the reciprocal of, so we're going to compare that with k minus 3 all over 3. So what we're saying is that k minus 3 over 3 is equal to the negative reciprocal of this, which gives k squared, so minus 3k plus k, so minus 2k minus 3 equals 12. So k squared minus 2k minus 15 equals 0, which would be k minus 5, k plus 3. So k would be equal to 5 and minus 3. So let's add that to the previous values of minus 8. So we have 5 minus 8 minus 3 plus 8 and a quarter. So that plus a quarter, so 2 plus a quarter, so 2.25 is E. Woo! Okay, we're getting into the tail end. We're getting into the tricky bit. I'm going to keep an eye on the clock now. So 17. Circle C is defined by that equation. N is a positive integer. So the circles, n increasing, you get different circles. C1 and 2 are drawn in the area between them as shaded. 3 and 4 are drawn in the area between them as shaded. So that's 1 and 2. That's 3 and 4. I'm getting an optical illusion here where I'm seeing the internal bit here being shaded, but I'm guessing they're trying to tell me it's not supposed to be, because I think that's 1, 2, then 3, 4. Okay, so let's get a look at this equation in more detail. X squared plus y squared equals 2nx plus 2ny. So x squared minus 2nx plus y squared minus 2ny is 0. So x minus n squared minus n squared plus y minus n. Okay, minus n squared equals 0. So x minus n squared plus y minus n squared equals 2n squared. So the center is at nn, and the radius is root 2n, because it always goes through the origin. This all tracks. So in other words, the first area, so importantly though, this is the radius. So the area from 1 to 2 is going to be pi r2 squared minus pi r1 squared. Let me try and do this generally. Where r squared was equal to 2n squared. We had that from before. So the difference between the two consecutive things is 2 pi n2 squared minus 2 pi n1 squared. So it's 2 pi into n2 squared minus n1 squared for the general case. And then we're going to do it so it's going to be 2 pi. The first one's going to be 2 pi into 4 minus 1. And then it's going to be 16 minus 9. So it's the squares, and it's all the way up to 100 circles. Do I know the sum of the squares? So it's the sum of all of the even squares minus the sum of all of the odd squares up to 100. I think that the sum of n squared is the square of the singles. So it's a half n squared n plus 1 squared. Oh man, I don't remember my series sums. That's a problem. I wonder if that's even on the spec though. Right, I'm there on how to solve the problem, but I actually have to solve the problem. I wonder, because it's the difference of two squares, if I call that 2 pi n2 plus n1, n2 minus n1. There we go, because n2 minus n1 is always going to be 1 here. So it's going to be 2 pi n2. That's more like it. That's much more like it. That is so much more like it, because then that is just going to be 2 pi, the sum of all the numbers from 1 to 100. And I know that. So the sum of n is a half n plus 1. Cancels, cancels. It's going to be pi into 100 times 101. So the answer is E. Nice. Glad I took an alternative path there. Okay, so 18. How am I doing? Half an hour. For 5 questions. Okay, so you're given this sum. The value for k is chosen as an integer in that range. All possible values of k are equally likely to be chosen. What is the probability that the value of s is a finite number greater than 3? So first of all, it has to have a sum to infinity, which puts conditions on what this can be. So we're multiplying so that r is equal to 2k over 7. And I know that the modulus of that, oh, come on, has to be less than 1, which means that 2k over 7 has to be in that range. I'm getting lag, and I apologize. So this is the actual value that k can have. So first of all, that's how to be a finite number. But then how can I be greater than 3? So the sum to infinity is a over 1 minus r. And that sum has to be bigger than 3. So 4 has to be bigger than 3 minus 6k over 7. So 6k over 7 must be bigger than minus 1. So k must be bigger than minus 7 over 6. So if I add that in here, k has to be bigger. So actually, let's put a number line on it. So that's minus 7 over 2. That's minus 7 over 6. That's 0, and that's 7 over 2. In order to have a finite sum, it must lie in this region. But in order for that finite sum to be, this condition also has to be true. So actually, minus 7 over 6 has to be less than k, less than 7 over 2. So the length of that line is 7 over 2 plus 7 over 6, which is 21 over 6 plus 7 over 6, which is 28 over 6, which is 14 over 3, is the length of the line allowed. And that probability, how much is that out of the length of 10? So the probability is 14 out of 30, which is 7 over 15. All right, I'll come back and check on this. I'm close. I can feel it. That's why that's frustrating. 26 minutes left, but I want to make sure I have a good attempt at everything first. So 19, solution to the differential equation, that is that. Which one of the following is the correct expression for f of x? Let me draw this out. Minus 6x. Well, y equals minus 6x. I have a negative gradient like that, and then go like that. And that's what the gradient is. So the gradient so in other words, dy dx is equal to minus 6x for all x is less than 0. So we can just say that y is equal to the integral of that, which is minus 3x squared plus c for negative x. For positive x, I can say that the gradient is instead equal to 6x, so y would be equal to 3x squared plus c for positive x. And when x equals 0, it's equal to plus c. So therefore, what it gives these the same? I think that is 3x mod x plus c. Because when x is positive, mod x is just x. When x is negative, this becomes minus x. So I think the answer is D. Okay, lock that in. 20. $25 left, okay. Maximum value of 2 at 1, minimum value, okay. Find the difference between the max and min values f of x squared minus f of x. Well, this is interesting because if I squared this up, these would all become positive. This would still go to 0. You would still get, you'd have 1, 4. This looks like an odd function, so I imagine when I square it, it's going to become an even function. So I think that's the square, where that's going to be minus 1, 4, and that's going to be 1, 4, and that's 0, 0. And the original, which I will also draw on, did something like this, where that is 1, 2, and that is minus 1, minus 2. What is the difference between the max and min values? So the minimum value that it can be is 0 out in the extreme over here. And the maximum value it is 6. So I think the answer is E. And I'm willing to lock that in because I've got 3 more questions to get to. So 10, 14, 18. Okay, let me actually have a go at this. So 10. What I'll do, so if it's 4 strips between minus 2 and 2, that means I need minus 1, 0, and 1 as well. When x is equal to minus 2, square that up for 4, you get 0. When it's minus 1, square that up for 1, it'd be root 3. Then it would be 2, then it would be root 3, then it would be 0. Root 3, 2. So okay, so this half base, I see what's happening. Oh, I see what's happening. So half base is 1 times height is root 3 over 2 for that triangle plus um, average of the parallel sides. So half of root 3 plus 2 times the height of 1 plus average of the parallel sides. Okay, so it becomes half and half makes that 1. Half and half makes that 1. So it becomes 2 root 3 plus. Nope. Wait. Half and half. So there's one lot. So it's one lot of root 3 plus 2 plus one full lot of root 3. So the trapezium rule gives me 2 plus 2 root 3. Now, I think this looks very trig to me. To find the exact value. So I'm going to choose to use the substitution. X equals 2. I'm going to use cos or sine. I prefer to integrate cos. So 2 sine theta. Because that looks very triggy to me. So the integral from, now when x equals minus 2, sine theta is minus 1. And that would be minus pi over 2 to pi over 2 of the square root of 4 minus 4 sine squared theta. I feel like this is not the technique to use, but it is a technique. Dx d theta is 2 cos theta. So dx is equal to 2 cos theta d theta. Now, that is 2 root of 1 minus sine squared x, which is cos theta, times 2 cos theta d theta. So it is the integral of 4 cos squared theta. And I know I do that by cos of 2 theta. If I just know it's sine, though. All right, no, I'm just keep going with it because I know it's going to get me an answer. That is equal to 2 cos squared theta minus 1. So 2 cos 2 theta is 4. I'm curious to know what the actual solution path is here. Okay, so it's going to be the integral of minus pi over 2 and pi over 2 of 2 cos 2 theta plus 2 d theta. So that is plus 2 theta between pi over 2 minus pi over 2. So in other words, it's sine pi plus pi minus sine of minus pi minus pi. These are both 0, and it's just 2 pi. Oh, it's circle. Oh, you son of a... Or maybe, I don't know. So the point is the exact one is 2 pi. So we've got 2 pi, and we're comparing that with 2 plus 2 root 3. So it's either 2 into pi minus 1 minus root 3, or it's going to be 2 into 1 plus root 3 minus pi. Which one exists? 2 into pi minus 1 minus root 3 is B. Lock that in. At least I get a point. So now I got 14 and 18 to go. 16 minutes. Not bad, actually. I didn't like this. I much preferred 18. I want to have another go at 18. Because I liked what I was doing there. I think I had that right. A over 1 minus r is the sum to infinity. And that has to be bigger than 3. Okay, must be bigger than minus 7 over 6. That is correct. And a sum to infinity must exist. And for a sum to infinity to exist, then that 2k over 7 must lie between minus 1 and 1, which puts restrictions on it. In fact, why don't I make my life even easier here? Let me just work in 6k. So in truth, if k has to be bigger than minus 7, it can't go as low as minus 21. So I know that the truth is that is the restriction on 6k. And I also know that the restriction on 6k, and that's out of 6k being between minus 30 and 30. So out of that 60, you're allowed to occupy 28 numbers, which is 14 out of 30, which is 7 out of 15. Maybe I'm missing. Okay, maybe I'm doing this wrong. All possible value cases. Oh my god, it's an integer. Nah. Okay, so it's an integer in that range. Okay. I'm there. I am there. So actually, there are 61 numbers between minus 30 and 30 inclusive. And for that not to be equal, so it's between minus 6 and 20 inclusive. So there's 27 numbers that can be. No, lies. So here, it can be minus 6. Maybe I'll go back to the original. Because I think I had that. Okay, so let's go back to the original 10. Because I'm missing the fact that these, sorry, the original 18. Because I'm missing the fact that these are integers. So in other words, if that's my true restriction, then I can pick 0, 1, 2, 3. So I can pick 4 numbers out of the 11 possible. No. Oh, I forgot minus 1. So it's 5 out of 11. Yes. Okay. So it's E. So that's 18 done. Now the only thing left to do is 14. And I've given myself 11 minutes in which to do it, which is good because I knew it would take. Oh, no, I hated that. Okay, so what have I already done for 14? Now, this is kind of cheating in that I don't think you would still have your working unless you kept it. Um, and in terms of M. Oh, have I just been a flaming moron? I absolutely have. Okay, let's go back and try this again. Because I did not differentiate the constant away. So here, if I actually differentiate properly, I'm going to get 2x squared plus 4mx plus 0 is equal to 0. Haha, the plot thickens. So 2x into x plus 2m equals 0. So either x equals 2 or x equals minus 2m. M is positive, so this one is definitely a negative number. So it is definitely minus 2m there and 0 there. So if I plug in minus 2m, this value becomes minus 16 over 3m cubed, 4m squared, plus 8m cubed plus n. And this is 0n. And we need it to go like this. So we need n to be negative. And we need this thing to be positive. So we need n to be bigger than 16 over 3m cubed minus 8m cubed. So we need n to be bigger than 16 minus 24 minus 8 over 3m cubed. So I think the restriction is A. So now I think I have 9 minutes left with 20 answers submitted. First thing I'm always going to do is check to make sure I actually do have answers for every question. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 answers submitted. Good. Okay, that means I've got time to check if I want time to check. I've got 8.5 minutes. What do I think I need? And the real thing, I wouldn't waste the time. I don't think I'll do that here either. So how would I check this? I've checked to make sure I have answers to every part of every question. Okay, so here, I imagine I was fine with those. So that is true. And that is true. That is true. Well, I mean, let me just check that 6 and minus 2 work in there. So that would be 2 minus 1 is 1. Good. 3 minus 2 is 1. Yep, that actually does solve. And that plus that is 4, which is F. I like it. So here, if I try and set them equal to each other, b squared minus 4ac is negative because they do not meet. Minus 10m, 25, minus 36, minus 11, minus 11, 1. So 11 minus 1. And they don't meet, so it has to be less than 0. So it's between there. I like it. Here, I did like that. That was fun. The integral between n and n plus 1 is just equal to the number on the top. So that is 1, 2, 3, plus 2, plus 3, plus 3, minus 4, minus 4, minus 5. I did like that method. 5 minus 4 is 1. I like that. 6.5 minutes left. So this one, I liked the method as well. So when I add 2 pi, it just becomes pi over 3 again. So I think a equals root 3 over 2, r is minus a half. I like that. This one I liked as well. That's the largest possible value of x. That's the biggest, unless I'm missing something, but I'm fine with that. In theory, that should be fine. I liked this. A lot. I liked that. That was very fun. This felt a little dodge. 5 minutes left. Am I going to get anything meaningful done? Just reassurance, to be honest. No, it's all right. Let me see if I can do anything. So I liked how I did that to make that A, and then I liked how I did that to make that right angle, making that 30. That was an isosceles, so I split that in two. That's two congruent triangles, so that's also 30. But that was 90, so instead of making that 30, but that was 30, making these same angles, so that's also A. And that's 120, sine 120. Sine 60 root 3 over 2, that's root 3 over 2. I did like how I found that. So I do think I did like that. So here, I found two possible values of cos theta. So there are 2 minus 1s, and there are 3 1/3s. So I do agree with 5 solutions. I did agree with this. Could have got there faster, but I did agree with it. So this one, this is just checking my work. I've got 3 minutes left. How many solutions? 3 solutions there, 4 solutions there. Yep, like that. I like that when I actually did it correctly. So 2 and 6 gives me 2 root 10 between the centers, and then add a further 8. So I like that. This I liked when I did it correctly, but let me just maybe check my algebra. So that's minus 8m cubed, so minus 16 over 3m cubed. 4 and 2 is 8, 8m cubed. 24 minus 16, so that would have been 8. And I move that over, so minus 8/3. I do like that. Okay. I really enjoyed that. I think I got that well. So there are 2 possible values of A, and they sum to 3. 2 minutes left. I liked how I did this with the gradients, so I'm happy to lock that in. This I feel good about. This I feel good about now that I understand that it's an integer. Out of the 11 possible integers, 5 of them work. This I liked. Do you know what this I liked? I'm gonna lock it in. I know I've got 2 minutes on the clock, but screw it. Right, and in fact, okay, what I'm gonna do now I realized I got the solutions, but I didn't get the actual answer key. So let me find that real quick. So TMUA 2023, paper 1. Whoop. Press buttons. I should never press buttons. Answer key. Let me just check that real quick. Cool. Alrighty then. So how did I do? Let's go back to the top. F, good. A, yes. C, F, E, F, B, E, something, B, F, something. Okay, so 15 I got wrong. Okay, that's annoying. So let me write that down. So I'll keep going just for momentum. So 15 I have to go over. 16E, 17E, 18E, 19D, 20. 20 I got it wrong as well. That's annoying. 10 was B. 18. I think I went and did that earlier. This was 14, which was A. And 18 was E. Okay, so it means I got 2 wrong. So 18 out of 20, not bad. Let me get into it and see why I got them wrong. So 15 and 20. So let's start with 15. That was just annoying because I really liked that as well. Did I just misread the question? Because this will inform, because this is what you do, right? You do a run and then you think, what did I do wrong? And that informs your next run. The difference is 3. Find the sum of the possible values of A. Oh, I suppose that assumes that A is bigger. I wonder if it would have been different. Should I have considered the case where 1 over A is bigger? Yeah, because that would have given me a different quadratic. So if I'd done that, then 1 minus A squared equals 3A, which means that 0 is equal to A squared plus 3A minus 1. Okay. Although, does that give me a different... A is equal to minus B. Oh my god! Plus or minus the square root of nonsense. That is so clever. So the sum of these guys would be minus 3, and then the sum of all 4 would be 0. So is 15 the answer A? No, it's F. Ah, how am I getting this wrong so many times? Right. What am I doing? Take me out of my misery. Here. I got that. Assuming A is bigger than 1. We get that. Yep, so we get this quadratic. So I knew I was on the right path. Oh, that's what I didn't consider. We need A as positive, so I didn't consider what... Okay, so these weren't all actually valid. I understand. Okay. So I wasn't thinking enough about the actual constraints of the problem here. Okay, so clearly, okay, how am I going to update my process then? So solving a quadratic, but when you do your plus minus, you need to check that all of them give you valid roots that you're looking for. Okay, good to know. So actually here, a valid one here would have been 3 plus root 13 over 2. And here, the only one here would have been minus 3 plus root 13 over 2. Because the negative case would also give you a negative a. And if you add those together, the minus 3's would cancel and you just get root 13. That makes sense. Okay, fair enough. You got one over me. That's valid. I just messed that up. Now this one, I liked this. I liked it. I thought I'd done well. What did they say the answer was? 20 was F. Well, it's definitely 0 there. So that's 6 and a bit. Well, f of x, it goes through, it definitely has a 0 point. So there's a value at which f of x is equal to 0. So 0 squared minus 0 squared is 0. So the minimum value of that, oh, wait. So that can get down to 0. Yeah, no, I want to check the full solution here. I'm not seeing this. What did I do? What? Y equals g of x. Why are we considering this, though? Why are we considering y equals x squared? We will then substitute f of x into this expression once we understand the behavior of y equals g of x. I'm assuming that means x squared minus 1. Okay. Okay, I see where I went wrong. So that's fair enough. That just conceptually got me. What I missed was the signs. So what I missed is, so I did sketch it correctly, but what I missed is that this can be less than f of x, so that this thing can be less than 0. Because, for instance, what happens in the case where f of x is equal to a half? Then in here, you'd have a quarter minus a half, which would be minus a quarter. And so that could have been negative. And that's what I forgot. So that's what they did, is they did it. I would never have thought of that in the real thing, though, as you could see. I didn't think of that in the real thing. But they did it in general. For it would be a negative of minus a quarter when x is equal to a half. So now what they're doing is they're substituting in f of x into there. So when f of x equals a half, you get a value of a quarter. So that gives you your minimum value. And then I like what I did with the graph. The graph got me my 6 quite quickly from here. So I liked the 6. I just missed my minus a quarter. Fair enough. Fair enough. All right, what I'm going to do now. So that was a valid 18 out of 20. And I'm okay with those marks lost. Sometimes a question just bests you, and there's no shame in that. Now I'm going to go through and see if there's anything I feel I need to explain in further detail before wrapping up. So here, I think that was self-explanatory. Same thing here, just making sure that when you have two graphs not meeting, you would, in order to do that, you would try to find where they would meet. And they would meet with simultaneous equations. So both would be true at the same time, and I can substitute one into the other, which is how I formed this quadratic. And then you would attempt to solve it, and if they don't meet, then there are no points of intersection, so no solutions of the simultaneous equation, so no solutions of this quadratic, which means that the discriminant is less than 0. And from there, you're off to the races. Now, here, this comes from understanding things about how the integral works. So the two things you need to know here are that integral from a to b plus integral from b to c is equal to the integral from a to c. So you can split out the integrals. And the integral from a to b is equal to minus the integral from b to a. If you know those two things, this question cracks wide open. So that's how I said integral from 0 to 3 is 0 to 1 and 1 to 2 and 2 to 3. And then 1 to 3 is 1 to 2 and 2 to 3, etc. And then I was able to here say that is equal to minus the integral from 3 to 4 and minus the integral from 3 to 5, which is 3 to 4 and 4 to 5, both subtracted off. Here, I think this was pretty self-explanatory. This is a good technique for any sort of sums question. Try out the first few terms, see if you can spot a pattern. And I did spot a pattern. I spotted a geometric series, which means it fell out quite nicely. Here, notice how I didn't do a full Pythagoras on that. So this is quite helpful, actually. To find my root 2 of 10 minus x, this is quite a common technique for making your life a lot easier when you're dealing with triangles in a non-calculator or an algebraic setting, is I knew that because that was a line of symmetry, that was going to be at sort of 45 degrees. So I knew that was going to be x and that was going to be x in order to maintain the symmetry. So I knew this was 10 minus x and 10 minus x, which means I knew they were the same length, which means I knew it was some multiple of the 1, 1, root 2 triangle, where that multiple was 10 minus x here. So I could immediately just say it was going to be root 2 of 10 minus x. And same thing here, the multiple was x, and so that became root 2x there, which enabled me to work out the area of the triangle with relative ease. But those ideas, that scaling triangle is quite an important skill. Here, yeah, let me explain this in more detail. So here's what I was thinking. So I was thinking that in order to be divisible by 12, you must be divisible by 2 squared and by 3. What I knew is that for all of these middle terms of the expansion, it would be 2 to some power bigger than 2, and 3 to some power bigger than 1. So all of these middle terms have a 3 and have a couple of 2's in them. So these will all be divisible by 12. The only terms in which that condition is not met could be the ones at the end. So what about when there's 1, 2, and multiple 3's? Well, in this case, the 12 gave me my other 2, so this is still divisible by 12. So the only way it's possible is here at the end where I have no 3, and here at the end where I have no 2. Now, there are not 12 terms of the expansion, there are 13, going from 12 choose 0 all the way up to 12 choose 12. So they're inclusive of 0 and 12, that's 13 terms, and only the 2 at the end are not divisible by 12, so all 11 in the middle are. Here, love a good self-quadratic. I don't think I need to go into too much detail there. This one, I did not like how I drew that. But if I kind of zoom in on it, maybe you can see how it worked a bit better. So here I drew, it just sort of looked very 30, 60, 90, so I tried it and it did work. If not, I would have pivoted. But then I know that was the big one because I was thinking, how do I get the other one? How else can I draw my length A and still intersect this line? I knew it was going to be, so that gave me the acute angle. So the idea here, why is there any ambiguity at all? And this is in the syllabus, and this is due to the sine rule. So let's consider this angle Z. So sine of Z over the opposite of root 3a is equal to sine 30 all over a. And I know for my 30, 60, 90 triangle that sine 30 is a half. So that becomes 1 over 2a. So I know that sine z is root 3a all over 2a, where these cancel down. So sine of z is equal to root 3 over 2. But remember that root 3 over 2 has a couple of solutions. So that means that z is either equal to 60 or 120. And so this big one is the solution of 60, and this one is the 120 for 30, which might even have been a faster way to get there. But that ability for sine z to contain multiple solutions below 180 degrees for a triangle is why two triangles can be drawn. So they found both triangles. And you'll see, so I knew that I was going to have to draw the A up to make that angle obtuse. And that there was going to form an isosceles triangle. And if I draw the midline through the isosceles triangle, I knew it was going to form 90 degrees there. And by looking at all the angles, 60, 30, 90, 90, I knew it was going to split the isosceles triangle clean in two, which means it bisects that angle to make it 30 and 30, which means these are congruent. This is 90 degrees, so 30 and 30 already taken means 30 is left. That 30 and that 30 are the same. Angles at the base of an isosceles triangle are the same, which means that these two lengths are the same at A, and I found that length of 120 that way, instead of using the sine rule. But that was my thought process, right? And from there, I got this triangle and was able to work out the area of T and thus get that ratio. Possibly tricky to spot. So if you need a tactical skip there, absolutely no shame in it. This was pretty self-explanatory. They really like this in the TMUA, working out how many solutions there are. So you need to find out what cos of 3 theta is in this case. And then, what's happening there? And then use your graphing skills to work out the number of possible solutions, being very careful about whether the extreme values are included or excluded. So transforming cos 3 theta, it would have had 360. Now its period is 120. So half the period is 60. So you get 1.5 cycles, getting you between 0 and 180. So there are 2 minus 1s. And there are 3 1/3. That's how I got that. Here, I want to see what they did, because I know I did this the suboptimal way. So let me see what I actually did for 10. So, because I know you can't be asked to do this, the integration by substitution. Was it just a circle? I bet it was just a circle, you know. Why did I not see that that was going to be a circle? Because if it was, let me check if it was a circle. Because what should I have spotted? It looked there. Okay, the fact that I was drawn to trig, and trig is found from the unit circle, should immediately have got me suspicious. But that really is just half a circle of radius 2. And pi r squared would have been 4 pi, and half of that is 2 pi. Like, but how should I have spotted that? What are they saying about 10? What context clues did I miss about that being a circle? Just squaring it up. Yeah, There you go. That'll do it. Circle radius 2. Damn. Man, I made my life a lot harder than I needed to there. So the square root was a problem, so I should have squared both sides and then could have spotted, oh, that's just going to be a circle of radius 2 centered on the origin. And that's going to be the semicircle. Would have got me there so much faster. Trapezium rule I actually did easily in comparison. But that's, okay, how I could have spotted the circle. Here, I think that was okay. Like I say, I kind of wasted the effort of finding the y's as well on 11. Where is 11? But I imagine I did a very similar thing to what they did. Oh no, they even found the y's. So yeah, same thing. And I think that was okay. The only thing I'll point out here actually is the convenience of when to differentiate and when to complete the square. So completing the square is a faster way for getting the turning point of a quadratic in general. But here I didn't like the k squared out in front. The fact that I'd have to factorize that out, it would have ruined things. So in this case, I chose to differentiate and set to 0. But once I got to here, and I saw this, which was divisible by 2, and there was no number in front of the x squared, that indicated to me, absolutely, let's go ahead and complete the square. I liked how I did 12, which is another one of how many solutions. Getting things to the same base so that you can compare the powers, quite a common technique. Never dividing through by signs squared because you will lose solutions. And I think the rest was okay. This, okay, let me draw how it should have been done properly. So I just made a little execution error there and forgot that this y would be negative. So we've got like 4 and minus 5, which looks something like that. And we've got 2 and 1, which looks something like that. But the point here, and I mean, it looks nothing like that, but the point is we do that and we carry on with our 4 in both directions. So that's 4, that's 4. These are the two centers. If I work out the distance between the two centers and then extend it by 4, that's how you're going to do it to get the maximum distance, where that then becomes 6 down, that becomes 2 across, and then you're off to the races. I was able to spot that, though, which is what counts. Well, I say that. My answer wasn't there. If they were sneaky, they would have put my answer in and lulled me into a false sense of security. Here, I messed up the first time because I didn't make n go to 0 when I differentiated. But this is quite common. So working out the number of roots of a cubic up, you find the turning points, and they have to be on either side of the x-axis to have 3 distinct real roots. So differentiate. Let me find when I did that properly. Here. Differentiate set to 0. Find your 2x coordinates. M was bigger than 0, so this had to be negative. So this had to be the one on the left, which has to be the maximum. So when I plug that in, it has to be bigger than 0. And when I plug in x equals 0 into here, I get n, which has to be less than 0. And then I combine those to get a. This, as we've established, there were two things I didn't consider. First of all, I made the assumption that a was bigger, which was not necessarily true. Well, in fact, what I should have done, yes. Okay, so the reason for the ambiguity at all was because it wasn't certain whether a was big, whether a would be the bigger one or 1 over a would be the bigger one. And what I should have clocked is in both cases, you're only going to get one option. So I should have clocked that by doing this, I was implicitly saying that a was bigger than 1 over a, which implicitly was saying that a had to be bigger than 1. And certainly a had to be bigger than 0, which is why I should have been suspicious when getting a negative a result. And same thing here. I should have been suspicious getting a negative a result here. And so that was the case where A was the bigger one. This is the case where 1 over A is the bigger one. I just wasn't rigorous enough with all my possibilities here. This I think I got once I did, and I'm curious to see whether they agreed with me that doing gradients was the easiest solution path. Yes, they did it by gradients. And we will have done exactly the same thing. Yeah. So they just considered every possibility of having gradients be perpendicular. Here, again, this was tough until I spotted the trick. Of completing the square on that, because they're consecutive, n2 minus n1 is always equal to 1. So it really was just the sum from 1 to 100 there. Is that what they did? Oh, they were explicit about the fact that that was consecutive. Okay, and if you plug in, so n plus 1 squared, and then, yeah, that makes sense. Although I actually prefer my path to theirs, because that's not as fun to do. I prefer mine. Because the n2 minus n1, and it would have been 1. So it really would have been just 2 pi 1 plus 2, and then 3 and 4, and then 4 and 5 and 6. So it really is just 2 pi times the sum of all the numbers from 1 to 100. Yeah, go on. I found a better one than them. Take mine. And that, by the way, is what I find with some of my students. They're bringing me questions saying, I did not understand what they said, and I'll sometimes come up with a different path that works better for our brains. Here, yeah, I just needed to clock integer. I was happy with that. I was thoughtful about the constraints on having a sum to infinity at all, the constraints on R, and the fact that it had to be bigger than 3. I just didn't think about the fact that it had to be an integer. But and again, if they were annoying, they would have put my answer in as a trap, as a red herring. But the fact that it wasn't there let me know something was wrong, which is why I went looking back at the question and eventually found this integer thing. 19. I like that I split out the different branches. And then I just considered which of the possibilities would give me this, and it was very clearly going to be either C or D, because E doesn't account for the positive branch, F doesn't account for the negative branch, and the others are just different. So at this point, the knowing that for positive x, the modulus of x will just be x. So for positive x, this would just turn into 3x squared, which is what I have, meant that D was the correct answer. And we've been through 20, where I did well to get most of the way there. I got my 6 for being the maximum. I just didn't look at that and consider the minimum from just completing the square. So I could have just completed the square on that, which is weird. You don't think to do that with functions. But I could have considered the fact that this could be less than that when these things are fractions. Okay, right. I'm satisfied with that. So as you can see as well, with paper 1, the logic is not there in the way that it is with paper 2. You still need to be as rigorous. I think my sort of looking at, I remember I've had these issues in the past. Is it polynomial or is it function? Is it continuous or is it just integer values of x and k? Those sorts of things I need to keep looking out for. And I need to be very careful about whether I'm making assumptions, but the math is just objectively not as difficult as paper 2. You can still find some issues sort of with the harder questions in paper 1, but on the whole, paper 1 is a time to sort of rack up your score and give yourself a bit of a net, a safety net going into paper 2. Have a look at my exam technique through that, where especially there was one moment where I just realized that I wasn't even on track to get anything close to the multiple choice. So I went looking for execution errors there. So that was good. I was also good at look how much I was checking the clock because I just didn't trust the pacing there. I ended up being okay, but I would want to do quite a few of these papers to get a sense of the pacing of it. Obviously very different than the ESAT where it's just all sprint all the time. So by running through all the papers, that's what you're getting is a sense of that. Timing, I don't think there was anything too extreme in this paper. And you'll notice, by the way, as well, like if you see a path that's going to work, but it's going to take you time, do what I did with question 10 and tactically skip it. And once I did that, I had enough of a time bank to come back to it and do it properly without too much stress. I will also say about question 10, I didn't see the optimal solution path, but I had a skill, so I used it and it worked, which is what I recommend for you too. I think that's just about everything. So with that, work hard, have fun, and I'll see you guys next time. Take care.